Hello, everyone. Thank you for joining our webinar this morning. We have another great presentation put together for you today. My name is Misha Lalou, and I am the marketing specialist for DynaEnergetics. I will be the host for today's webinar. Our panelist today is Thilo Scharf. Thilo is our product line director here at DynaEnergetics. He has been with the company since 2011, and his main areas of interest are perforating technologies, explosive safety, and well completion methods and techniques. Thilo, thank you for being on the call with us today. Before we get started, Thilo, could you please give us a quick outline of today's presentation?
Absolutely, Misha, and thank you very much for the kind introduction. Good morning, good afternoon, and good evening from wherever you join us. Today, we're very excited to announce the official launch of the newest member in the DynaStage family, our DS Echo perforating system for Re-Frac application and unconventional wells. In today's webinar, we'll mostly focus on a quick introduction to Re-Frac stimulation operations. We will look at the application process and design considerations of the DS Echo system, as well as the DS Echo system key features. We will take a closer look at the Re-Frac charges that are inside the DS Echo system. And at the end, we will have some time for questions and answers.
Thank you. So throughout the call, if you do have any questions, please type them in the Q&A function located on the bottom of your screen. And as Thilo said, we'll be monitoring the questions and we will be answering them towards the end of the call. So we have a lot of great topics we'll be covering today, so we're going to jump right into it with our very first question. So Thilo, before we dive into the specifics of DS Echo, I'd like to talk a little bit about Refrac. So for those of us who might not be familiar with Refrac applications, could you just give us a quick refresher and some background on what it is?
Absolutely, Misha. Refrac stimulation is a great method to address underperforming wells with known issues or known reasons. And those issues could be that the well stopped producing or never produced much at all, that the production has declined below an economic point. Maybe some additional bypassed pay has been identified. Maybe the cluster spacing of the original design was too great, and again, potential pay was bypassed. Or just in general, the initial design of the completion was non-optimal, and with today's knowledge, we would like to go in and just rectify this. All the shale wells might be a really, really good candidate for recompletion, given us an opportunity for a second chance or just another go to make a well much better. So conducting refracturing operations is a very attractive value proposition to maximizing wellbore profitability and the EUR of an existing oil and gas asset. It can provide an immediate boost to production by delivering more stages, tighter cluster spacing, and more proppant per lateral foot. Recompleted or refractured wells can provide greater formation access, which most often results in a higher production, which is what we're after. So recompletion or refracturing can be achieved in several ways using several methods and techniques. The three most common ones are diversion, coiled tubing frac, and mechanical isolation. The diversion and coiled tubing frac applications work with the existing well infrastructure, and in the case of diversion, diverters are pumped to close off existing perfs, and we can shoot new and frac those zones. Likewise, with coiled tubing frac, existing zones are straddled with straddle packers and shorter sections of tubing, and we're fracking through the tubing individual zones. Now, for our purposes, we're going to focus on the mechanical isolation, because this is where DS Echo fits in, and mechanical isolation and block on perf. Mechanical isolation really is a new liner, either cemented or expanded, that is put into the existing well and cemented into place, and it really provides a complete wellbore isolation from heel to toe, and essentially allows the operator to begin with a brand new well completion or a clean slate, so to speak. So DS Echo really is the ideal system for wells that are mechanically isolated with expandable liners or newly cemented tubing strings.
Thank you for that background. I think having that quick refresher, I'm sure will be helpful to our audience as we talk further about DS Echo later on in the presentation. So you talked about some of the benefits of Refrac. Could you now touch on some of the challenges faced for plug and perf in a Refrac application?
Absolutely, Misha. So mechanically isolated wells prepared for refrac operations usually present themselves with a reduced wellbore diameter due to the slimmer casing or tubing that's been installed into the existing infrastructure. Smaller IDs usually also mean smaller guns. Smaller guns mean smaller shape charges. Smaller charges mean less explosives and less energy available. So while running slim guns is generally not a problem, in this particular case, we ask those slim guns with the small charges to actually deliver quite a high performance, having to penetrate through 2 casing layers and 2 layers of cement. So really, this is a smaller gun with less energy that is expected to do an awful lot more than a normal gun. Smaller guns also mean smaller entry holes in the casing itself. And again, that's usually not a problem because you can hydraulically fracture through a very small entry hole. What that usually means, though, is that perforation friction will be a lot higher, pump rates tend to be lower, the time per stage tends to increase, and the results can fluctuate greatly. So really, providing ideal entry hole diameters and uniformity across all facings through both of the casing strings, the inner and outer, is essential for any successful refrac campaign. And all of this is made even be more challenging by the inner casing or the inner liner usually being installed eccentric, providing an unequal distance and cement thicknesses that we have to overcome. Another real important challenge that we face would be secondary fracture growth in an undesired direction. And that could be within the cement in between the two casings, which would be very undesirable because it diverts energy away from the formation.
Thank you for that insight. You mentioned that DSEcho is purposely designed for refrac operations in existing shale wells. So as you were involved with the development and the design of DSEcho, could you explain why the DSEcho system is the ideal tool for refraction operations and give some detail on what key elements make for a successful refrac perforating system? And then maybe just touch on what are some of the differentiators of DSEcho.
Definitely, Misha. So let me answer this question in a two-parter. First, I'd like to focus on the shape charges of DSEcho and then the DSEcho system itself. So on the shape charge side, considering the challenge that we've just discussed with regards to the smaller casing and such, what we want and what we're after are open perforation tunnels all the way to the formation with a really good hole size and the uniformity across all facings. These factors are all essential to achieve formation breakdown and pump the design amount of sand and fluids with the available horsepower that we have on surface. Also maintaining the cement isolation, as previously mentioned, between perforation and clusters without secondary fractures in the cement is absolutely critical. So with regards to the system itself, DSEcho, this was a ground-up grassroots approach with every component in the system being purpose-designed and built to work as a system, as a unit. And really this was done to foremost increase safety and also to reduce traditional failure points that we see in plug and perf operations, to increase the reliability overall of the plug and perf system, the ease of use to the user, and ultimately to streamline plug and perf operations. The small diameter of the DSEcho system makes it an ideal choice to use in recompletion and refrac plug and perf operations. As I said previously, the gun itself can be run inside expandable liner or cemented tubing strings and still packs enough punch, perforating punch, to penetrate those multiple layers of casing and cement. DSEcho is also ideal if you have a wellbore that has a minimum restriction that doesn't allow for a bigger gun to be run, so you can use the slimmer DSEcho systems.
Those images are great visuals as you walk through that explanation, and made it really helpful to follow along and really understand the approach that was taken. So DynaEnergetics adopted the factory assembled performance assured concept by introducing DynaStage to the industry. So now with DS Echo, we've combined all the benefits of that system and created a separate system specifically for Re-Frac applications. Can you give us a brief overview on the meaning of that phrase, factory assembled, performance assured, and then just talk about what customers can expect as far as manufacturing standards of DS Echo compared to some of our other systems they may be already familiar with?
Absolutely. So all of our DS family products are factory assembled and quality assured. And in doing so, we really have transformed the perforating industry from component sales to fully assembled and quality controlled system, which we believe is an absolute new era in perforating solutions. All of the explosive components are designed, manufactured, and engineered in-house by DynaEnergetics. The entire system, once assembled and quality controlled, can be delivered to the well site, to the customer, per customer specifications. Like all other DS family products and DynaStage products, DS Echo is manufactured at our DynaEnergetics ISO 9001 compliant facility in Plum, Texas. We see a very nice image of that facility here. The manufacturing processes are very tightly controlled and must adhere to strict manufacturing processes to be certified field ready. So serving the complete DynaStage product line, the Plum Center utilizes a combination of in-house machining and outsourced manufacturing to produce gun carriers and components such as tandem subadapters. In addition, 100% of all the initiation products and ballistics are manufactured in-house, and this includes detonators, shaped charges, detonating cord. And what that means, it gives DynaEnergetics complete control over all these critical parts in our perforating systems. Like all other DS family products, DS Echo is enabled by our reliable plug-and-go IS2 top 5 intrinsically safe initiating system. This particular detonator is very easy to install at the well site and requires no on-site wiring or crimping. It's as easy to install as a battery in a flashlight. Once installed, the complete plug and perf string can be fully tested before running in hole and also while running down hole until the gun is initiated. Intrinsically safe detonators are a vast improvement over standard addressable switches and resistorized detonators, allowing uninterrupted communications and are immune to unintentional initiation, for example, by stray voltages, stray currents, or high frequency communication devices, or even megavolts.
Thank you. Again, I love that detonator. Again, makes it really easy and simple to understand. So before we move on to our next question, I would just like to remind everyone that if you do have any questions for Thilo, please submit them using the Q&A button located at the bottom of your screen. And like we mentioned, we will be answering questions towards the end of the presentation. So Thilo, can you now talk about what type of perforating charges does the DS Echo system use?
Absolutely, Misha. So DS Echo was designed with its own brand of compact refracturing shape charges, the EchoFrac. So EchoFrac charges are specifically designed to perforate 2 casing string layers, 2 layers of cement before reaching the formation, but still have enough perforating power to penetrate the formation with adequate entry hole diameters. At the same time, EchoFrac charges do not damage the cement sheath between the primary and secondary casing, as well as the casing to the formation. This here is a very good picture that shows the casing between the inner and the outer string, whereas we peeled back the outer string just to expose the casing layer, showing that there's absolutely no cracks or fractures between the individual perforating ducts. These cracks, as previously mentioned, would be very undesirable and would allow for fracture pressure to find the path of least resistance and connect in the cement sheath for perforation hole-to-hole connection. This could and will reduce the effectiveness of fracture stimulation inside the formation. So maintaining this cement integrity and casing integrity is extremely important for Refrac operations.
Mm-hmm. So earlier on, you mentioned the importance of entry hole diameter. Can you tell us what entry hole diameter can be achieved with DS Echo? And can you discuss what the tool sizes available are, and then maybe just explain what casing strings are applicable?
So DS Echo charges come in two different sizes, 11 gram for our 2.5-inch DS Echo system, and a 15-gram system for the 2 3/4 DS Echo. The 2.5 diameter DS Echo system is usually used in wells originally completed with a 4.5-inch casing and recompleted with a 3.5-inch casing or tubing cemented in place or a respective expandable liner. The 2 3/4 diameter system, which is usually run in wells that were originally completed with a 5.5 or 6-inch casing and recompleted with 4-inch casing or again respective expandable liner. The operator itself has a choice of 2 different entry hole diameter in both gun sizes, and they are 0.25-inch entry hole diameter and 0.30. And really, depending on the design and fracture design, the customer can choose between those 2. The diameter that can be achieved themselves are independent of the gun position itself relative to each other and the casing, and refer to the effective smallest entry hole through both casings. So effective diameter is the smallest one through both casings into the formation. The charges themselves are called EcoFrac DP25 and EcoFrac.
Thank you, Thilo, for all of the information you covered today. We've had a lot of great questions coming from the audience, so now I want to transition to that and try and get to as many of those questions as possible. So our first question from the audience, is DS Echo available as an oriented perforating system?
It is. So DS Echo is available as 2.5-inch DS N line and 2 3/4 N line with the EcoFrac charges. So yes, absolutely, that can be done.
Mm-hmm. So our next question, how does DS Echo differ from products your competitors may have on the market?
Excellent question. So we believe our competitors are looking at only part of the equation, which would be the shape charges, which is a very, very part of the equation, but in our eyes, not the full part of the equation. In our eyes, it's the shape charges as well as the system those charges go into that make a perforating system.
And then another question that came in is, what is the maximum swell of DS Echo guns?
So the maximum swell is usually determined on surface and our surface tests under worst case conditions. So absolutely no confining pressure. And also we use what's called hot charges. These are slightly overloaded charges. And what we get for the 2.5-inch system is a swell just over 2.6 inches. And for the 2 3/4 is a maximum swell of just over 3 inches. Again, operators should not see this in a downhole scenario, as those are absolute maximum values.
And then the next question that we have is, how does hole size and penetration compare to other 2 3/4 inch products that may be available on the market?
Those would be comparable, but keep in mind that DS Echo and the EcoFrac charges are designed to deliver those entry hole diameters through both casings, basically not giving us any pinch points once we start the fracture stimulation.
Mm-hmm. Another question that we had come in, how many DS Echo guns can you link together and shoot effectively?
That will depend on the length and configuration of the DS Echo gun. If you have a single shot or 2-shot gun, that would be shorter and you can combine more together. Theoretically, with very short guns, we can deliver up to 100 individual guns per run with our IS-2TF initiation technology.
Mm-hmm. And then, let's see, another question here. Could traditional plug-and perf operations benefit from using the technology inside the DS Echo shape charge?
A lot of that is obviously proprietary, but all of our charges, especially for frac applications, go hand in hand. So we will look at geometries and liner plans, and these things do interlink, and we learn from other systems when we bring something like DS Echo to the market.
Mm-hmm. So I think there's a couple more questions coming in. Let's see if I can get to them. They're coming in really fast and I'm having trouble scrolling to them. Give me 1 second.
That's excellent. That's excellent. we like a lot of questions. And if we don't get to answer them in this particular call, we'll get back to the people that asked them in writing. So it's absolutely.
Yes, definitely. The next question, what is the shortest length available?
The shortest TS echo would be a single shot. So it would be just with one single charge if a customer chooses to do so.
Okay. Another question we had, is there any option or near future development for a Re-Frac completions application that have bigger gun size to perforate a casing, liner, overlap for a conventional completion by getting constant entry hole and acceptable formation penetration?
If we need to increase our gun sizes, we can do this absolutely, and we can also apply the technology that we put into Refrac charges into bigger charges. Right now, we haven't looked at it. For the moment, we're concentrating on the 2.5 and the 2 3/4 system, but a 3 1/8 system or bigger is not out of the question by no means.
Thank you so much. So one other question. Let's see. Again, they're coming in really fast. Let's see. What is the gun configurations one shot up to?
Repeat that question, please, Misha.
What is the gun configurations one shot up to?
I'm not sure I get that question. So a single shot gun could be run oriented either up or down or sideways if the customers would want, or just randomly. I'm not sure if that answers that particular question.
Okay, and we can also go back to that question for the person that asked that, and we can follow up with you by email.
Absolutely.
So I think we're close to running out of time for today, so I think that wraps it up for today's webinar. Thank you to Thilo for your time today, and thank you for everyone for attending and for all of the great questions. Apologies if we did not get to your question. If we did not have a chance to answer it on this call, we will be following up with you by email after. And if you do have any other questions, please submit them to, we're going to put some email addresses up on the screen. You can submit those questions to either of those email addresses on your screen. We'll also put up a QR code just in a second on your screen. And if you open up the camera on your phone and scan this code, it'll take you to a survey where you can provide us with feedback on today's webinar. We would really appreciate any of your comments and any feedback that you can provide. And thank you again for attending, and we look forward to having you join our next one. Details for our July webinar will be coming out soon. So like I said, any other questions you have, please submit them to either the email addresses that you see on your screen, and then make sure you scan that QR code so you can provide us feedback from today's webinar. Thank you so much, and we'll see you in our next one.
Thank you, Misha, for hosting.
Thank you, Thilo.